Hi, good morning. Now we are going to talk about the chapter gravitation. Gravitation, gravitational field, acceleration due to gravity, gravitational potential energy, potential, all these things are going to talk. Gravity or gravitation. Any body attracted towards the earth, any body is attracted towards the earth, we call it as gravity. Acceleration due to gravity means freely falling body experience an attractive force, experience an acceleration towards the earth. Or when you move the body against the gravity, it is reverse. When it is attracted towards, we can say the term G to be positive, acceleration due to gravity. When it is moving against the earth, you are moving the body like this, vertically upwards. Then value of G is negative. When it is coming down, it is attracted towards. So the value of G is positive. Okay. Now, what is called weight? Weight is nothing but a force. Force experienced by a body towards the center of the earth. Weight is nothing but a force. Generally, by Newton's second law, we are writing F is equal to ma. But here, F is replaced by W and A is replaced by G. Acceleration due to gravity. Fine. In the case of Newton's law of gravitation, another form, Newton's law of gravitation. Any two bodies in the universe or any body in the universe attracts any other body with a force which is directly proportional to the product of the masses and inversely proportional to the square of the distance between them. Suppose you have two bodies of masses m1 and m2 separated by a distance r. Then, by Newton's law of gravitation, their experience an attractive force which is directly proportional to product of the masses m1 m2 and inversely proportional to the square of the distance. This is known as Newton's law of gravitation. It is called Newton's universal law. Why we call it as universal law? It is applicable for any two bodies in the universe. So the name universal law of gravitation. Or F is equal to constant capital G m1 m2 by r square. This capital G we call it as gravitational constant. Small g we call it as acceleration due to gravity. Small g. And capital G we call it as gravitational constant. Sir, I want to know the unit, I want to know the dimensional formula of capital G, and I want to know the value of G. You know very well, small g acceleration due to gravity is 9.8 acceleration. So the unit is meter per second square. Whereas this value G is 6.67 10 power minus 11. It is a constant. Now we have to write the unit. G is equal to F R square by M1 M2. Don't mug up the unit and all. From the formula you can derive. F R square, F is force, R is a distance. So I can write Newton meter square. Mass into mass. Mass is expressed in kilogram. So you can write kg into kg square. Numerator will become kg power minus 2. So the value of gravitational constant is 6.67 into 10 power minus 11 Newton meter square kilogram power minus 2. Okay. Dimensional formula we want. How to write? F force dimensional formula MLT power minus 2 because it is mass into acceleration. R square, distance square, so L square. By M1, M2. M1 is mass. Mass into mass, so M square. One M get cancelled. So dimensional formula of G. Take this M to numerator. M power minus 1, L cube, T power minus 2. SI unit is Newton meter square kilogram power minus 2. Dimensional formula of capital G is M power minus 1, L cube, T power minus 2. Correct? Okay. We want to express this Newton's law of gravitation, that is the force, in vector form. How will we write in vector form? We know the formula F is equal to G M1 M2 by R square. One body of mass M1, another body of mass M2. Distance is R. R12, R21, F12, F21. So, force experienced by second body over the first body, G M1 M2 by R12 square, R12 cap. Capital G is gravitational constant. M1 M2 mass, R12 distance, R12 cap. This is called unit vector. Here they will put a negative sign. Why we have to put a negative sign, sir? The force of attraction, anywhere the attraction word is there, you should put a minus. Suppose you have a positive charge, you have a negative charge. It is going to attract 1 plus 1 minus. What is the force? Same on the product of two charges. One north pole, one south pole coming close together attract. There exists a force of attraction. Product of pole strength. So here, product of masses, attraction. So minus. F12 vector minus GM1 M2 by R21 square R21 cap. So right answer also vector form, left answer also vector form minus. Okay, so this is the vector form of Newton's law of gravity. Acceleration due to gravity and gravitational constant, we should know the relation. relation between small g and capital G. Suppose the body is placed on the surface of the earth. This is earth, center of earth. Mass of earth is capital M. Radius of the earth is capital R. You are placing one body here of mass small m. Then what is Newton's law of gravitation? F is equal to G capital M small m by capital R square. The distance between the center of the earth and the surface where the body is placed. You call it as the distance is nothing but radius here. So I can write G mm by R square. The weight experienced by the body on the surface is mg. Mass is m, weight is mg. Equate, both are attractive force. mg is equal to g mm by r square. Cancel. G is equal to gm by r square. Acceleration due to gravity is equal to capital G, gravitational constant, m, mass of the earth, or radius of. You substitute the values. Sir, I want to calculate mass of the earth from this equation. No problem. You can calculate. M is equal to gr square by capital G. G 9.8. Radius of the earth nearly 6,400 kilometers. 6,400 kilometers is the radius of the earth. Huge value. 6.4 into 10 power 3 kilometer or 6.4 into 10 power 6 meter r square by capital G 6.67 10 power minus 11. Substitute, simplify it. 5.98 into 10 power 24, nearly 6 into 10 power 24 kilogram. This is mass of the earth. Huge, huge value. 10 power 24 kilogram. Mass of the earth. Sir, I want to know the density. You can calculate. What is density? Rho. That is mass by volume. Mass m 4 by 3 pi r cube. Perfect sphere. Volume of a sphere. Calculate the radius. Substitute. Calculate the density of the earth. Nearly 5,500 kilogram per meter cube. You are getting. Simplify the values. 6 into 10 power 24. Radius value is 10 power 6, nearly whole cube. So that is 10 power 18. 10 power 18 numerator, 10 power minus 18. 10 power 24 minus 18, 10 power 6. Simplify remaining things. You are getting 5,500 kilogram per meter cube. That is the density of the earth. Okay. The acceleration due to gravity g is always constant, 9.8 meter per second square. But when you go towards a very, very, very high altitude, The value of G is not a constant, it changes. When you go down below the surface of the earth, depth, the value of G changes. Earth is not a perfect sphere, it is slightly elliptical in shape. So, due to shape of the earth, that is latitude, the value of the upward gravity changes. Minor change only, but there is a change. Variation of G with altitude. Altitude means height. Earth, mass M, radius R. Take this as point A. Consider another point B, which is at the height of H. At this point only, we have to calculate what is the acceleration due to that. Small G value, we have to calculate at this point B. How to calculate? G suffix A on the surface of the earth. What formula we have related? Capital GM by R. GB GM by center to this point. What is the distance? R plus H the GB by GA. GM by R plus H the whole square by will become into R square by GM. Cancel. GB by GA. R square by R plus H whole square, you take R outside. So here you have a square. So R square will come out. 1 plus H by R the whole square. Cancel. Take this to numerator, you will get 1 plus H by R whole power minus 2 GB by GA. Expanding binomially, but there is a formula called binomial expansion. 1 plus x whole power minus n. 1 minus nx plus nx square by factorial 2 minus nx cube by factorial 3. Like that it continues. 1 minus nx plus nx square if you put, you will get x by r the whole square. Denominator r square will come. R value itself is too high, very, very high value. So R square and denominator is extraordinary high value. Denominator is more means total value is very small. So we are neglecting. Neglect the higher terms. The value is 1 minus 2h by r. GB is equal to GA. What is GA? That's nothing but G. Acceleration, normal acceleration due to gravity. So GB at a height h given by the formula G into 1 minus 2h by r. So G minus some value, that means acceleration due to gravity decreases when you go away from the earth surface. It is not a constant, it is very high altitude only, of course. 10 meters, 15 meters, 1 meter, 100 meters, no problem. Beyond that, there is a change. The change is small, but there is a change. Okay, next. Variation of G with the depth. variation of G with the depth. Point A, at a depth D, we have to calculate. You know very well, Earth, mass capital M, radius capital R. At a depth D means remaining should be R minus D. So formula GA at the surface, we will take it as G. Formula GM by R square, basic formula. GD at a depth, this point B. G dash we will take. GM dash by R dash square. Sir, why you are putting M dash? Mass is a constant. Definitely mass is a constant. But here we are considering the entire surface of the earth, the huge one, that mass is M. When you come down to the point B, the surface is reduced. Portion of the earth is small, the size is small, so definitely the mass will change. Volume reduced. Volume reduces with mass. The mass is volume into density, so mass also reduced here. So I am putting M dash. So G dash by G is equal to G M dash by R dash square into R square by GM. Cancel. G dash by G is equal to M dash. What is M dash? Mass is volume into density. Volume 4 by, at this point we want 4 by 3 pi R minus T the whole cube. Mass into density rho into R square. Divided by 4 by 3. This is basic formula. 4 by 3 pi r cube mass into R dash square. What is R dash? R minus T the whole square. 4 by 3 pi, 4 by 3 pi cancels. R square, R cube means 1 R remaining. R minus T whole cube, R minus T whole square. Only 1 R minus D left out. So I can write G dash is equal to G into R minus D by R. R minus D by R. What you are getting? G into 1 minus D by R. That means G minus some value again. So ascent of gravity decreases with the depth. This is second point. Variation of G with altitude, variation of G with the depth. Next. Variation of G due to change in shape of Earth, latitude. When Earth is rotating, that is different. We are considering Earth is not rotating and we are deriving the formula. We have a separate formula derivation. Variation of G with latitude due to rotation of Earth. That we are not going to discuss here. What is called shape of the Earth, sir? It is not a perfect sphere. It is an ellipse. Towards the equator, the radius is different. Towards the pole, the radius is different. So this is RP, this is RE. What is the formula? G is equal to Gm by R square. Basic formula. Relation connecting capital G and small g. Mass of the earth constant. Gravitation constant capital G is a constant. So I can write G proportional to 1 by R square. So for the equator, GE is equal GE proportional to 1 by RE square. And at poles, GP is equal to R proportional to 1 by RP square. Sir, acceleration due to gravity and radius is inversely proportional. So when R is greater, center of gravity decreases. From the diagram is very well understood. RE greater than R. So equator radius is bulged. So equator radius is more than the top pole radius. So denominator is more. What will you get? Since RE greater than RP. Here RP is less compared to RE, RP is less. So denominator is less, mean total value is more. GP greater than. Towards the pole, acceleration due to gravity is more than acceleration to gravity near the equator. Small change only, but it is not a huge one. Small 9.76, 9.72. Here 9.8. Small change.